Oh my gosh, it's 11:20 and there's only like 5 of us here. Guys, class has started, so I'm going to go ahead and get started. Cuz I start right on time. So it is 11:20 and welcome to Trigonometry Review Day. We're going to get right started. So just to get things going, we're going to be jumping right into a review. So you will have a homework assignment tonight. And it will be on WebAssign. So I'm going to show you really quickly how to log into WebAssign and get going there. Okay. All right. So let's take a look at what we're going to be doing today. So the first thing, let's make sure that we can log into WebAssign. So showing you guys how to do that. So how to log into WebAssign. If you go to Google Classroom and you click on classwork, okay, you'll be able to, if you go to my syllabus, okay, so syllabus right here. So if you click on that syllabus, so, and I'll just go over some really quick things, some quick things. I'm Mr. Kraft, Miss Morris and Mr. Race, we all work together very closely. So we're gonna have the same syllabus, the same office, different office hours, but same content. We all do the same stuff. My office hours are there. They're in the morning. We'll go over that just a little bit. This should all be the same, but just down here at the bottom. So this is how to log into WebAssign. So you guys need to be logged into WebAssign. Okay, so. Oh man, so you have an account but you don't know your password. So you're going to have to send me an email then, and we'll have to figure out what to do there. You might have to make a new account. So I don't know. It should be your school email, so make sure you're using your school email. So let's just make sure you guys are logged into WebAssign today. I don't have time to do that because you guys should have already logged into WebAssign for a previous class. So make sure you do that. Make sure you use the class code. Okay. And make sure that you're enrolled in the right class. If you have issues, I'm going to be able to troubleshoot that at the end of class, or you can send me an email. But this is the last class of the day, so if you guys want to troubleshoot that, we can do that at the end of class. But you do have homework. It will be due next class. You have to be logged into WebAssign. Okay? All right, and again, all of this password and stuff is on my syllabus, which is accessible through the classwork tab here. Okay? Some other things that you guys need to note on the Google Classroom, right? Zoom link for class is right here. I would also suggest adding this to your Google Calendar so that if you want to see what my Google Calendar looks like, I have all of my classes for the day set up here. So for example, I have Algebra 1, I have my office hours, Algebra 1, Geometry, and then now I'm in Pre-Calc. And then when I click on it, I can just go click Join Zoom Meeting. So I have this set up for all of my classes throughout the whole week. I know when assignments are due, okay? And so it's just a really good way of doing all of that and being organized, okay? So I would highly recommend that you guys do that. So again, for Zoom links, you can also add it to your calendar for my office hours. Links to class videos. So one thing so some of you guys I haven't had before. So you'll notice that, again, links to class videos. When I click on the links to class videos, takes me to a YouTube playlist where it says Pre-Calculus B, 3rd period spring. Don't go to winter because that's not our class. Already I put a video of an online tour that I made a long time ago. But if you come here, all our classes will be posted here. Now, before you guys freak out, because I see some wonderful people have their cameras on, and I really appreciate that. Thank you guys. When I post this to YouTube, the only thing that's being posted to YouTube, see how I'm wearing headphones, is my voice and what you see on your screen. It's not your video, it's not your voices, it's not the chat. Okay, so it's totally safe, it's totally secure. There's no need to worry about sharing in class. Okay, just want to make sure you guys knew that. You don't have to but if you subscribe to it, then it's just really easy. You go to YouTube and you can check out lessons. Now remember, everything we do is open note, right? So YouTube is part of your notes. So make sure you guys have that as there. I'm not going to post assignments in Google Classroom, but there is a permanent link here just to go to WebAssign. You will always have homework every class without exception. So since you will always have homework, right, then you never have to remember because it's the norm. You will always have homework. Okay, we do have things that we need to get through today, but before I move on, does anybody have questions? You guys can use chat or you can turn on your mic. Oh, and before you guys start asking questions, one thing I do want to note is a lot of you were really late, and I start on time. So when I sent out the email today that I open up class at 10:05. No, what time for this class? 10:15, 11:15, 11:15. You guys need to be here before 11:20 because I get going at 11:20, and especially some of these lessons, I use the whole period. So if you missed it, you miss it, and you're gonna have to go to YouTube to get your information. So with that said, does anybody have questions or comments before I get started with our review lesson today? Oh my gosh, it's so nice to have people with their cameras on. I really appreciate it, guys. Thank you. Truly appreciate it. Okay, yeah, so I don't know what Zoom link you were using. So yeah, so whatever Zoom link was not working, don't use that one again. Don't use that one again. Okay. Anybody else have questions? All right. So I'm going to go ahead here and we're going to get started. So if you're following along, remember if you need a physical book, you can always grab a physical book from the school, check it out from the library. If not, you guys can follow along with the online book that is on WebAssign. So today what we're going to be doing is we're going to be doing 4.4, and that is a trig review. Okay, so I'm going to just take some time and show you guys how to do some trig review. Okay. All right. So, sorry, I gotta close some windows now because I had all these windows up showing you there. Oof. All right. Okay. So, one last note. The only thing that's different from when you guys had pre-calc A, so whether that was first trimester or second trimester, it's super important that if you guys need an extension on an assignment, you need to email me. Okay, so I just really want to make this super clear. If you want an extension, you have to email me an extension, like email me after you have asked, because I won't know. So if you ask for an extension on WebAssign, it doesn't send me an email. So ask for an extension on WebAssign, right? You guys can do that. And then email me saying, hey, I asked for an extension, so I know to go in and approve it right away. Okay? Because if not, then it's just whenever I log in, I might see it. And then you need to email me after you turn in an extension. Because if you turn in an extension, I don't get an email saying that you turned anything in. So email me after you request an extension, and email me after you complete an extension so I know to update Skyward. If not, then you're going to have all these assignments turned in, and Skyward will be like, why do I have an F? Right? So make sure you communicate with me. If you communicate, we'll be able to do anything, guys. We'll take over the world. Well, maybe not anything, but we'll get close. Okay? So let's review trigonometry. Okay? So trig is a big deal. And at some schools, trig, I'm glad that you're here. And again, all these videos are going to be on YouTube. So if you miss something, you can go on YouTube. And what's cool about YouTube is you can slow me down, you can pause me, you can speed me up, whatever you want. Okay? And again, if I'm going too fast or if you have a question, use chat to ask. A lot of you already know how to use the direct message, because if you direct message, it's private. I will never say your name if you send me a private message. I won't be like, oh gosh, like that's a silly question, John. Right? I'm not going to do that. Okay? All right, so let's take a look. Trigonometry is huge, guys. It is the fundamental building block of our universe, right? Think about this. Trigonometry takes triangles, which is the smallest possible polygon, right? And I don't have time to talk about this. Man, if we had longer classes, we'd have a good discussion. So triangles, remember, are so big that they had a cult. Did you guys learn about the Pythagorean cult? Right? Back in the days, right? Where like nighttime is the right time, right? They were really a cult, okay? And they believed triangles were the answer to everything. It was the universal building block. Everything was made up of not just triangles, but whole number triangles. Well, it turns out that they were onto something. Now, I'm not saying that we should all go join a cult, but maybe we should. Okay? I'm saying that they were onto something. It turns out that triangles actually are the building block of the universe, but not in the way that they thought. It turns out that triangles are actually circles. Did I misspeak? No. Triangles are actually circles. And it turns out that circles are actually waves. And it turns out that everything in our universe is a wave. Okay? You might have heard of string theory. Now, I don't have time to get into this, but you can obviously tell math isn't my subject of choice. I actually am a physicist. And so I just want you to know math is so beautiful and trigonometry is so beautiful. But we only have, oh my gosh, we only have like 20 minutes. So here we go. So draw a circle to the best of your ability. And let's put a little coordinate system in there. Okay, not a great circle, but it's not a terrible circle, right? Like, all right. So we're going to, I'm going to prove to you everything I just said. Okay? Physics is greater than math. Let's be real about it, right? I don't know if you guys know this, but Mr. Ingman and Mr. Hope and I all have the same degree, and we all married well, Ingman and I both married a social worker. We all have a degree from the same school, and we all have the same degree. So I am like Ingman and Hope, but younger and better looking. Though I do have less hair than Hope. That's something that's true. He does have me beat there, and I do look less creepy than Hope. And if you have Hope today, or if you have Hope tomorrow, you can tell him that Krept is throwing him under the bus. He'll appreciate that. All right, so here we go. So if I have a circle, and I have some point on that circle, x, y, well, we know how circles work, right? They have a radius. Oof, come on, Krept. All right, my pen is dying a little bit. So they have a radius r. Okay. Now what's cool, if we draw this is a Cartesian plane. If I draw this in a Cartesian plane, it's going to have some x to the right, and it's going to have some y up, right? That's how we get our point, because x represents left to right, y represents up and down. But boom, I just made a right triangle. And there you have it, guys. If you take this blue point and you go around the circle, every single circle on that, every single point on that circle is part of a triangle. Right triangles are circles. In fact, Pythagorean connected it all. He just didn't go further with that. And that is, if this is a right triangle, then I know, and you know, that the legs squared equals the hypotenuse squared. But what is this? This is the equation for a circle. And a formula that only works for right triangles is the equation for a circle. That should be blowing your mind, right? This only works for right triangles, and it's the equation for a circle. So a circle is a right triangle, because this only works for right triangles. What? Okay, and then what's even trippier is that if you cut this circle, if you cut that circle, and let's say we take a look at the height, so I start at 0, I go up, I come down, and I come back down, right? This is a graph of sine of x. This is just the circle cut, right, at pi, cut at 0 and 2 pi, and spread out, and now we have a wave. So right there, every single particle in our universe is a right triangle, because it's a wave, because it's a circle. Okay? All right. Kind of cool? Kind of cool. Okay. So a couple of things that we need to learn about. Sorry, I'm trying to sell it to you. Okay, so sine, right, has a maximum of 1. We're talking about a unit circle. It has a lower of -1. Okay, and then what are the key parts to a circle? Well, we have 0. And remember, we're going to be in radians, so we don't do this degree stuff. That's for engineers. No one likes engineers. And yes, I'm trying to start a fight, so come at me. Okay? So I have 0, and then I have pi over 2. And then I have pi, 3 pi over 2, and 2 pi. Okay? And remember, we always go clockwise. Okay. I just realized that I need my... All right. So sine of x, right? We think of that as our height. Oh my gosh, height. Is it I before E in height? No, it's not. Okay. Hey, I feel better. Height. Okay, so sine of x, we think of the height. It's the y. It's the up and down, right? Whereas cosine, right? So I have 1, -1. That is... This is cosine of x. This is considered to be the width. Blue pen is dying. Don't die on me, pen. I loved you. Why don't you love me back? Aww. Okay, there we go. Okay, so cosine of x, you can think of it as the width. Okay, and it actually turns out that sine and cosine are just the same thing, just shifted pi over 2. But I digress. That has to do with, if this is a 90-degree angle, what do the angles in a triangle add up to? 180. So that means these two angles add up to 90. So they're just 90 degrees difference. Crazy, right? Anyways, don't have time for all of that. So we need to keep going with what 15 minutes is not enough. Okay? So just doing a little trig review. And if you guys have questions, please let me know. Are we doing okay, guys? Just doing a review. Hopefully I haven't said anything that you guys don't already know. Okay. So the next thing I want to talk about is SOHCAHTOA. And every time I teach this, there's always one kid who mishears me. I'm not saying SOHCAHTOA, because that's gross. Okay, unless you're into that, I don't judge. Okay, SOHCAHTOA. So that means, right, sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. And tangent of theta equals opposite over adjacent. Am I going too fast? Absolutely, because this is review. So remember, with review, you're writing down notes when you're like, oh man, I don't remember that, right? But SOHCAHTOA, right, is just saying the S goes with sine, the O is opposite, the H is hypotenuse. C goes with cosine, the A is adjacent, the H is hypotenuse, and tangent is opposite over adjacent. Okay? Neat. You're going to learn a lot about tangent in calculus. Okay. And then, so just some other ones, right? So let's talk about the reciprocal. Do we need to know the reciprocal? That is a great question, Mr. Kraft. Yep, we do need to know the reciprocal. Okay, so the reciprocal ones are cosecant. So that's 1 over sine. You need to know secant. That's 1 over cosine. And you need to know cotangent. And that's 1 over tangent. Now, I call them reciprocal because reciprocal means flipped. Right? So do you see how cosecant is 1 over sine? So sine is flipped. You're not going to have these in your calculator. So to do them in your calculator, you just do 1 over the sine of them. Now, how do you remember this? The way I remember this, they're flipped. I kind of think of them as backwards. Because notice how cosecant starts with a C. You would think it's cosine, right? And you notice how secant starts with an S. You would think it would go with sine, but it doesn't. That always messed me up in high school. So I don't want that to mess you up. So make sure you have a way of remembering that. Well, it's also open notes too. I mean, there's that, right? Okay. All right. So I've gotten, I think, all the basic information down, right? Because it's been a quick minute since you guys have done trig, probably. Okay. So that's just a quick review. So now let's get into some example problems. I'm running out of time, so let's get into some example problems so you guys have some meat to your notes. It's not just like all for show. And it's kind of like I've just been spitting on my notepad right now because it's just kind of there. Does anybody have any questions or comments or? All right, you guys are speechless. That's wonderful. sometimes I just like talking to myself. It's not weird. Or is it? Okay, so let's talk about, okay, let's do some math with this. Okay, so let's say we have a point. Okay, so given point, let's say -3, 4. I'm just using the one in the book. So given point -3, 4 is on the terminal side of theta, find sine, cosine, and tangent. I feel bad because I'm using the abbreviations. Okay, so now this came with an image in the book. Am I going too fast? Are you guys doing okay? You guys getting this down? Okay, so if we were to look at this, what this means, so terminal just means end. Okay, so it just, I have a point and it's on the terminal side. So if it's -3, 4, that means I'm going to go left 1, 2, 3, up 1, 2, 3, 4. And that's going to be at some angle theta. Remember, we always start at 0, right? We always start at 0. So boom, right here. And then I can even write down the coordinates of this point. This is -3, 4. Okay, so what we're going to do is we're going to find sine, cosine, and tangent. Now I picked this one because we're in the second quadrant, so that makes it a little bit more juicy, right? Can you just feel the juice starting to come out of your corners of your mouth, or maybe even a little bit in your ears? Always clean your ears in the morning, guys. Or if you're like my dog, you got juice coming out your eyes. All right, so to do this, it's really important to note that when we're dealing with something like this on a unit circle, that this point are just the coordinates of this triangle, right? So we're going to use right triangles to help us out. So I know my change in x is -3, and I know my change in y is +4. Okay. 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 So sine of theta, right, is going to be, what do we have here? Opposite over hypotenuse. So it's going to be 4 over, we need the hypotenuse, don't we? So how am I going to find the hypotenuse? So the hypotenuse here is h. So I know that 4 quantity squared plus -3 quantity squared. Notice how I'm putting parentheses around these? Because if I have a negative, right, a negative squared is going to be a positive. So if you don't put parentheses around it, it's going to think it's -1 times 3 squared. So you have to put the parentheses around it. Okay, so if I solve this, it's going to be the square root of the quantity of 4 squared plus the quantity of -3 squared equals h. Let's do that. I have a calculator here. You can see it's just a basic calculator. Okay, so I'm going to take the square root of 4 squared plus -3 squared and just hit enter. I get 5. Now, some of you are like, crap, come on, like, you were just talking about Pythagorean's cult. How did you not know that was a Pythagorean triple? Whoa, it's not a Pythagorean triple because the -3, it's negative. So don't, whoa. Okay, now, yes, I did know, but I wanted to show people I use calculators too. It's okay. So what are we saying? H equals 5. Ooh, how beautiful. Gotta love whole numbers, right? So sine then is opposite over hypotenuse. So sine is 4/5. Now, how often in life are you going to be given a point to ask and then to find the ratio? You're not. It's just review, guys. I'm just trying to show you how it all ties together. Let's do the next one. Cosine of theta equals, okay, so cosine is adjacent over hypotenuse. So adjacent is -3 and 5. So I would have to have -3/5. Okay. And then if I wanted tangent, right? Like if I was thinking like, man, it's sunny outside, I want to burn my skin, I might go outside and not put on sunscreen. That's not what tangent means, but it could. So then I'm going to have opposite over adjacent. So I'm going to have -4/3. The negative default just goes with the top. I should have just put it out in front, but. All right, cool. Now, if I wanted to do cosecant, secant, or cotangent, I would just flip these, right? So for example, cosecant would just be 5/4, right? Do you guys see how I would flip it? Okay. Again, I don't have a lot of time, so I'm just trying to show you real basic stuff so that you guys can do your review assignment tonight. Are we doing okay, guys? Again, if you have questions, remember, it's not a YouTube video yet. You can still ask questions, okay? I appreciate you guys. All right, let's do this. I'm excited. Okay, so let's do some more stuff with trig. Okay, thank you. I appreciate the comments in the chat. All right, so okay, so that problem, it's important to know, right? What was this problem? We're given a point, we want to find the stuff, right? That doesn't happen very much. So what happens more likely is this. Is if you're given an angle, can you find the reference angle? If you're just given an angle, I'll show you what I mean by this. Okay. So here is, we're doing example number 2 here. So let's say we want to find the reference angle. Right? We want to find the reference angle. And what I mean by that is, degrees. Who uses degrees? Ugh. Makes me want to puke. Okay, so let's say theta. Sorry. Let's say theta equals 1, 2, 3, 4. Nope. 5 pi over 6. Okay. So what does that look like? Well, I have pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. It looks like this. Okay, so this angle right here is 5 pi over 6. If you don't remember that, I think didn't we do a review of radians first trimester? Is that what we did that? Do you guys remember doing that? I can't remember. I think we did this first trimester. We did a review of that, didn't we? So if you didn't have me first trimester, I'm sorry. And if you had me first trimester, I'm sorry. Okay, but if you guys need a review of radians, come to my office hours and we can do that together, okay? Because like, that sucks, we had a gap. So what this means is that even at that angle, I can make a right triangle. And then there's some angle phi, that's my reference angle. So when we say reference angle, we mean the angle inside of our right triangle that is on the x-axis. So if you need to take notes on that, right, it's not what I write, it's what I say, right? So the reference angle, right, it's that angle inside the triangle that's on the x-axis, okay? So we use the reference angle to do that. Now, you just have to be a bit clever in this case. So for example, if you look, do you see how this is, part of this triangle is touching pi, okay, which was pi day yesterday, okay? So we got pi over here. So if I want to find this angle, we just do some algebra, and I can say pi minus 5 pi over 6 equals my phi. Or if you're British, you would say phi, but we're not British, so. Sometimes Canadians say phi too. Oh, now I can't remember which one's the right one. Phi. I call it, we say phi. Theta and phi, yeah. They say phi. Like phi, phi, fo, fum. It's phi. All right, here we go. So to do this, I'm just going to get this as the same denominator. So 6 minus 5 is just 1. Okay, so that's how you find reference angles. Now be really careful. If on WebAssign it gives you degrees, then feel free to use degrees, right? So if this was degrees, right, you would just change this to 180, right? Now, again, it's really hard, and I'm really sorry, guys. It's hard taking a, some of you are taking a trimester break between A and B, and if you're in that case, I'm so sorry. Come to my office hours. We get you caught up. Come to my office hours. We can do our work together, okay? Because that's really tough. All right. So, do you guys want to try one on your own? Here, I'll be nice to you. I'll even let you do it with degrees. But remember, degree isn't just for men. that was a product joke. Okay. All right. All right. So let's say theta equals negative 135 degrees. I want you to find the reference angle. Okay, so why don't you guys try that one on your own? And if you get lost, it's okay to be like, Kraft, you know what? I'm lost. And that's okay. But try it and see what you get. It's okay to be lost, because that's why we're here. If you guys could do everything perfectly, you would be in AP Calc with either Hope or I. Well, actually, I don't know what I'm teaching next year. So secretly, so I'm glad you brought that up. Secretly, I've been adding rat poison to Ingman's and Paul's tea and coffee every day, but I think I did too small of amounts because I think they're building up an immunity. Shame, right? Just a shame. I would love to teach physics. I actually don't know why I teach math. I actually am not a big fan of math. Okay, yeah, let's talk about this. So negative just means we're going clockwise. Okay, now take a look at 135. We got to figure out what quadrant we're in. So we know we're starting at 0. We're going the opposite direction. It's more than 90, but it's less than 180. So it's going to be somewhere here. Now, this isn't accurate because I literally have no idea where 135 is. Well, I do. I just don't want to put the brain power into it. Okay? But what's important is if you can get it in the right quadrant, then I can go like this and make a right triangle with the x-axis. Okay? So then I know the angle I'm looking for, my phi, is that one. The angle with the x-axis, right? So I appreciate you guys that tried and got stuck. That's what this is all about. Does this make sense how I did this? This isn't something that I memorized. I'm just thinking about it. I know it's more than 90, less than 180, so it's got to be here. So I make this triangle. So this is 180, right? But here's the kick, right? And we just want the reference angle, right? But here's the kicker. I can't use negative 135, right? So and since I want this to be a positive reference angle, I can just do 180 minus 135, and that will give me this. Because we want a positive answer, right? We don't want a negative answer. Because I hope your previous teachers told you, right? Your calculator only does first quadrant trig. Because it would be too much to have all of it, right? But knowing how calculators do things, that's another discussion for another day, because they actually use shortcuts on calculators. We can break things with calculators. So it looks like that's going to be 45 degrees. And that's our reference angle. Okay, and that's an important skill to have. So again, I'm never going to say someone's name that sends me a direct message. All I'm going to say is, did that help out? You said you weren't sure. Did that help you out? Perfect. See, communication, everything works, right? And see how we build this trust? You guys can ask questions. I'll never call you out. Okay? All right. So why is this important? Why is this important? Because we want to be able to find things on the unit circle, and we have to be able to find reference angles. Okay? So I'm going to bring it all together now. So think about what we did. So given an angle, we found a reference angle, right? And what was the other thing we did? God, I have a short memory. We talked about what is trig. We talked about what are the ratios, okay? All right, so let's bring it all together. So what are we doing? And I think, oh gosh, are we done at 12 or 12:10? Oh, 12:10. Excuse me, I just burped on the mic. That's embarrassing. All right, let's go. So we're going to do now, so let's call this example 3. Sorry, guys, that this is kind of a crazy lesson, but I hope this is mostly review, yes? So I just want you guys to know I don't normally teach like this. This isn't a lesson. This is a review. Are we okay with that? I just don't... People are going to be like, wow, his notes are really scattered and terrible. I'm not self-conscious at all. All right, so example 3. So what we're going to do is we're going to evaluate. And we're going to do this without a calculator. And I'm going to tell you why we're going to do this without a calculator. Because I want exact answers. So we're going to get exact answers. Hey, while we're here, can we talk about cheating? I want you guys to know that if you cheat, I don't think you're clever. And it's really easy for me to identify when you cheat. So I just wanted to throw that out there. I'm not like previous math teachers. Like, there's math teachers at the school who think people don't cheat, which I think is funny. So I just want you guys to know, like, things like photo math. I'm like, when I make questions, I have photo math. I have it on my phone. Okay. And so I know what your answer is going to look like if you use photo math. And I just want to put that out there, that if you guys plan on passing this trimester by doing photo math, you're going to be in for trouble. Okay. Just want to throw that out there. Don't cheat. When you cheat, who do you cheat? You cheat yourself, because you're going to go on to college and you're going to take a math class and you're going to be like, I have no idea how to do any of this. Okay. All right. Whew. Man, I brought down the hammer there. All right, here we go. Evaluate. Let's evaluate cosine of 4 pi over 3. Anybody here have pi on pi day? No? All right, good talk. Just trying to build rapport with you guys, but it's all a ruse. I don't actually care about any of you. All right, so how do we do this? There's some steps. Let's put all of it together. Draw a picture. I don't know about you guys, but the further you go in math, the more abstract it's going to get. And any time that you can just sketch a quick picture, it's going to help. Oh, it's your sister's birthday. Happy birthday to your sister. What a glorious day to have a birthday. So remember, we always start at 0. Okay, so now where are we? We're at what was that? Oh, here it is. 4 pi over 3. So that's thirds. So if you guys forgot, all you need to do is memorize the first quadrant. So if you guys forget, this is pi over 6. This is pi over 4. This is pi over 3. Now, some people think I'm weird. Okay? And I am weird. Let's be real. I am very weird. But I hate counting in thirds. I love counting in sixths, because sixths are so easy to count. There's 2 sixths in every quadrant, and then you include a major axis. So for example, here's 1/6, 2/6. Remember, 2/6 is pi over 3, right? And then you have 3, 4, 5, 6. You guys see how counting in 6 is really easy? So what I like to do is I like to convert this to 6. So cosine of 4 pi over 3 is the same as cosine of, I'm just going to multiply the top and bottom by 2 here, as 8 pi over 6. It's a personal preference. If you like counting by thirds, more power to you. So let's see here. I have 1, 2, 3, 4, 5, 6, 7, 8. You guys see how I did that? Okay. So all I did is I know 6. I know there's 6 per, I have a list, but I'm so sorry. It's so hard to say that. I have 2 6 in every quadrant, and then you include the major axes as well. Okay. So that's 8 of those. So I get to here. I still want to evaluate this, right? Now, remember, there's symmetry. And this is the part that's really important. There's symmetry, right? So pi over 3, right, has symmetry with this, and then it has symmetry with this. And you should get these rectangles. Do you guys remember doing that in Algebra 2 or Pre-Calc? These symmetry things, right? So I know that my picture is terrible, but that's okay. Remember, it's just for guidance, okay? So what's important here is if we know the coordinates of pi over 3, we know the coordinates of 4 pi over 3. Because, and I wish this will work in blue. Remember, in the first quadrant, it's positive, positive for my x and y. It's negative, positive in the second quadrant. It's negative, negative in the third quadrant. And it's positive, negative in the fourth quadrant. Okay, so I know, and I'm just going to do all of them, just so that in case you guys forgot, right? So this is 1/2 root 3 over 2. This is, oh my gosh, it's root 3 over 2. No, it's root 2 over 2. No, it's a second. Okay, so something just happened. This is a teaching moment. I don't have these memorized. You guys ready? So this is just a special right triangle. Right, so 45, 45, 90. So if this is 1, and I want to solve for y, then sine of 45 degrees equals y over 1. So y equals sine of 45 degrees, which is, so it's a special right triangle. So this side is root 2 times longer than the short side. So if this is n, and this is n root 2, so n root 2 equals 1, so n equals 1 over root 2, and then I multiply this by root 2 over root 2, I get root 2 over 2. Okay, so this is root 2 over 2. If you don't know what I was just doing there, I was just using special right triangles. That's where this comes from. So if you don't remember that, you can come to my office hours. I'll help you out. And then this one, pi over 6 and pi over 3, that's another special right triangle, right? So that is the 30, 60, 90. Right? So you're just switching 30s and 60s. So this is root 3 over 2 and 1/2. I really hope that whoever taught you this taught you that the reason where you get these, right, is from special right triangles. Did you guys learn that? If you didn't, you should come to my office hours, because it's not like someone made this stuff up, right? That's what's cool about math. Everything is proven, right? Everything is proven. There's a reason for everything. The reason why you learn special triangles is because they make up the unit circle. So what's really important here is that notice how this pi over 3 and this 4 pi over 3 are connected. So the units down here is just going to be negative, negative. So this is negative root 3 over 2, negative 1/2. And it wants cosine. So we have to remember from the start of the lesson, cosine is our width. So then I know that cosine of 4 pi over 3 equals negative root 3 over 2. All right, did I go too fast there? I'm just a little worried for time. I want to be able to do a couple more of these with you guys. right? So everything I did led up to this problem, right? Being able to know the unit circle, to know about symmetry, to know about finding the angle, being able to do that stuff. Are you guys okay? Yeah, it was a little fast. Sorry about that. We'll do 2 more together. Sound okay? We'll do 2 more. It was a little fast. You have to remember, I get really excited sometimes, and if you guys don't say anything, you're just gonna let me get excited. I'm gonna get on that excite bike and just take off. All right, let's do another one. Let's do another one. Am I okay to move on? Okay. All right, thank you guys. All right, so let's do another one. So let's do, we're going to evaluate, I don't know what example, are we on 4? Let's evaluate, I don't know why I drew the V so big. Evaluate, let's do sine of 5 pi over 3. Now, do you guys want to do this together or on your own? I'll let you vote. Okay, we'll do it together. So again, what I'm going to do is I'm going to draw a Cartesian plane. Remember, it's not a coordinate system. You want to be cool. You want to be cool with your friends at your party over the weekend, right? So you're going to have your cup of tea. You're going to have your pinky out. Can you see my pinky? And you're going to be like, and then I drew my Cartesian plane. The pinky up was important. All right. So remember, we're starting at 0. And I don't know about you, but I like counting in 6s, okay? Because I think 6s are easier to count. So I'm just going to remember that, hey, this is the same as times 2 times 2. This is the same as 10 pi over 6. Because for me, counting 6s is easier. You do you, okay? So I'm just going to count here. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 5 pi over 3. Now, I want to slow down. Did you guys see how I got where that was? Right? So I use pi over 6, and then because I know there's 2 per quadrant, and then there's 1 on the axis. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 5 pi over 3. Okay. So I notice it's over 3, right? So I know if I go like this, that there's going to be symmetry. There's going to be symmetry in that circle between pi over 3 and 5 pi over 3. So from last time we learned this is root 3 over 2, 1/2. So if this is positive, positive in this quadrant, this is positive, negative in this quadrant. So that means the coordinate for this, I'm going too fast. I'm going to go slow. Sorry. Again, I got excited. How are we doing? Does this all make sense? We only have a minute left. I guess that's why I'm a little rushed. Sorry. Taking time to get people in web assigns took some time out. So what do we got here? We got, so this would be positive root 3 over 2 and negative 1/2. Right? So then we want sine. So then I know sine, right? That's my y. That's my height is going to be negative 1/2. Did I do that right? 5 pi over 3. 10 over 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that the right? Do I have that right? I think I have these wrong, guys. Shoot. Root 3 over 2 is more. Ah, my gosh. Okay. What we did was right, but these are backwards. Oh my gosh, guys. I'm so sorry. I had them backwards. I'm so sorry. I just realized that because it doesn't make sense. Root 3 over 2 is bigger than 1/2, right? So this one, the x has to be bigger, right? The x has to be bigger on this one. So that has to be root 3 over 2. So this one was wrong. This has to be, this is negative 1/2. I'm so sorry. Craft. Stupid. All right. Let's fix it. The process is the same, guys. The only thing is I just switched the numbers. I'm so sorry. Again, you can tell I don't have these memorized. I really don't. And I don't encourage you to memorize them either. It's a complete waste of time. But with that said, everything's open notes, right? So there you go. You guys went out this year. Pre-calc will never be easier because you have open notes. So I'm past my lesson time. How about this? I need to respect your guys' time.